Hi, students and friends. This is your host and teacher, Sayyid Ayazuddin Haider, and I'm continuing my O-level past papers session. And this time I've selected variant 21, and it's of October-November 2024. You know the times, 1 hour 45 minutes. It's paper 2 theory. You have to answer all the questions. You can use calculator in this paper. The total mark for this paper is 80. Periodic table is printed in the question paper. So let's start with question number 1. Number 1A. Figure 1.1 shows the electronic configuration of 5 atoms D, E, F, G, and H. So here's figure 1.1 showing electronic configurations of 5 atoms. Answer the questions about these electronic configurations. Each electronic configuration may be used once, more than once, or not at all. State which electronic configuration D, E, F, G, or H represents number 1, an atom of an element in group 6 of the periodic table. So here's group 6. If an element is present in group 6, it means it must be having 6 valence electrons, right? 6 valence electrons for group 6 elements, because the group number represents 6 as the valence electron. So count the valence electron for all of these electronic configuration. For D, it's 2. For E, it's 4. For F, it is 8. For G, it's 6. So G must be the final answer for this one. For convenience, I'm checking the last one also, that is H, and there is only 1 electron in its valence shell. So it's incorrect. So G will be the final answer. Number 2, an atom that forms an ion that gives a lilac color in a flame test. You see potassium, it's in group 1. It forms a lilac color in flame test, and the electronic configuration is 19, and it must be having 1 valence electron. But you have to count all the electrons. Looking out at these choices, I have H. If you count the electrons in H, it must be 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There are 19 electrons in H. So H must be the potassium that gives a lilac color in a flame test. So you'll write H here. Number 3, an atom of a monatomic gas. So group 8 elements, they all exist as monatomic gas. So the proton numbers, you have 2, 10, 18, 36. So any one of these having 2, 10, 18, or even 36. We don't see any atom with only 1 shell, because in the first shell you will have 2 electrons. So we can't have 2. What about 10? I can see F having 10 electrons, which means F must be the element from group 8. So it must be the having an atom of a monatomic gas. F is the final answer for this one. Number 4, an atom of an element that is used in the treatment of the domestic water supply to remove taste and odor. To remove taste and odor, carbon is used. Carbon is used. So carbon, where is carbon? Here is carbon. The proton number of carbon is 6. It means you have to look for the element that must be having 6 electrons. Total electron must be 6. If you look at the electronic configuration, E seems to be the right answer, because it's 1, 2, 3, 4, 5, 6. There are 6 electrons in this. So E must be the final answer for part 4. Number 5, an atom that forms a stable ion by losing 2 electrons. Now, if an atom loses 2 electrons, forms stable ion, it means it must be having 2 valence electrons. So D seems to be the correct answer, because you see there are 2 valence electrons, 1, 2. So it will form stable ion by losing this 2 electrons. So D must be the final answer for number 5. B. Deduce the number of protons and neutrons in the chromium atom shown. Small number is the proton number. So the number of proton must be 24. What about number of neutrons? You have to subtract the number of protons or proton number from the nucleon number. So 53 minus 24. The answer is 29. So 29 must be number of neutrons. Moving to next question, which is question number 2, part A. Iron is extracted in a blast furnace by the reduction of iron 3 oxide with carbon monoxide. Here's the reaction equation. Fe2O3 plus 3CO gives 2Fe plus 3CO2. 1. This reaction is a redox reaction. State the meaning of the term redox reaction. Redox reactions are those reactions in which oxidation and reduction taking place at the same time or occurs simultaneously. So I will write oxidation and reduction taking place at the same time or occur simultaneously. Number 2, explain how carbon monoxide acts as a reducing agent in this reaction. Now, carbon monoxide is removing oxygen from iron 3 oxide, which means it's gaining oxygen from iron 3 oxide. So you can either write it removes oxygen or gains oxygen. Removes or gains oxygen from iron 3 oxide. Part B. Calcium carbonate is added to the blast furnace. The calcium carbonate undergoes thermal decomposition. Here's the reaction equation. CaCO3 gives CaO plus CO2. The thermal decomposition of calcium carbonate is endothermic. Complete the reaction pathway diagram in figure 2.1 to show the reactant and products. The labeled arrow for the activation energy, EA, a labeled arrow for the enthalpy change, delta H. So for the endothermic reaction, product must be at the high energy state than the reactant. Product at high energy state than reactants. So reactant must be at the low energy state. So I'm going to show the reactant here. This is reactant and here's energy hum, and then we have product. So write down the symbols for the reactant, which is CaCO3. So I'm writing CaCO3. Products, we are having calcium oxide, which is CaO, plus carbon dioxide, CO2. Now they are saying labeled arrow for the activation energy. This must be the activation energy starting from the reactant side and reaching at the top of the hump. We are representing it with EA. And delta H, that is enthalpy change, must be between reactant and product. It's also going up because it's absorbing energy. So this will be the final label diagram for this. Number C, describe how slag is formed in the blast furnace. Include a symbol equation in your answer. Now you have to include symbol equation in your answer. So you have to describe first. So what's happening? It's actually calcium oxide that reacts with silicon 4 oxide. calcium oxide reacts with silicon 4 oxide. Silicon 4 oxide is also known as sand. You can even write the formula, which is SiO2. Now, reaction equation, which is CaO plus SiO2. The product obtained is calcium silicate, which is CaSiO3. Moving to next part, which is part D. Iron is a transition element. Transition elements have colored compounds. State two other physical properties that are typical of transition elements and not of group 1 metals. Here's group 1 metal, and here we are having transition elements. Transition elements are between group 3 and group 2 and group 3. So these all are transition elements. You have to write any two physical properties that are typical of transition elements but not of group 1 metals. You know, group 1 metals, they are soft, they have low density, low melting point, they are not used as catalyst, they have fixed valency, they have +1 as their valency or oxidation number. So these are the properties which are not shown by transition elements. Transition elements are hard. So you can write any two from, you can write hard or you can write high melting point. Transition elements have high melting points. High density. They have variable oxidation number. Or they can be used as a catalyst. Used as a catalyst. Group 1 metals, they are not used as a catalyst. So you can write any two from these. E, the equation shows the decomposition of iron pentacarbonyl FeCO whole 5 in a closed container. There is the reaction FeCO whole 5 L, reversible sign, Fes plus 5 COG. Number 1, predict and explain what happens to the position of equilibrium when the pressure is decreased. The temperature remains the same. Remember, this is a reversible reaction. It reaches to dynamic equilibrium state in a closed container, because they are saying in a closed container. So it has definitely reached to dynamic equilibrium state. So whenever reversible reaction in a dynamic equilibrium state, so the effect of pressure is that if you increase the pressure, the dynamic of the equilibrium, it will shift to the side with less number of moles or less number of molecules or volume of gases. But if decrease the pressure, the reverse will be true. So the prediction. So first of all, I'm going to write the number of moles, molecules, or volume of gases. So you will have better idea in which direction it will be. Number of moles, molecules, or volume of gases. So on the reactant side, it's 0. You can't see any gas here. What about the product side? It's for 5. We have only one gas, that is carbon monoxide here. So 5 moles of carbon monoxide. So if you decrease the pressure, it will shift to the side with higher number of moves. So equilibrium definitely shift to right hand side or product side. Now, what about the explanation? Refer number of moles. Refer number of moles, molecules, or volume of gases on either side of the reaction. Number 2, this reaction can be used to produce a pure iron. Describe and explain why, referring to the equation, how a sample of pure iron that is free from FeCO5L is produced from the equilibrium mixture. We need only iron from the reactant, and we have only one reactant. The reactant will be converting into products, and the products here are iron and carbon monoxide. Carbon monoxide is a gas, so you can have open system so that you will allow, or you are letting CO to escape. So you write open system. Or you can write let CO escapes, which means shifts equilibrium to the right hand side. You have to shift the equilibrium to the right hand side. And how you're going to do this? You will increase the amount of the reactant. F. Iron reacts with hot concentrated sulfuric acid. The products are iron 3 sulfate, sulfur dioxide, and a liquid that turns anhydrous copper 2 sulfate blue. Construct the symbol equation for this reaction. First of all, I'm writing the reactants. We have iron here. Symbol of iron is Fe. Hot concentrated sulfuric acid, it must be H2SO4. They didn't ask for the state symbols, so no need to write the state symbols here. What about the products? The products are iron 3 sulfate. Iron 3 sulfate means iron is carrying +3 valency or oxidation number. Sulfate, it is -2. Ignore the charges. Now swap these numbers. So you'll get Fe2. Fe2, I will write it down here first. Fe2 SO4 whole thrice. So Fe2 SO4 whole thrice plus. They are saying sulfur dioxide is also produced, so you will write sulfur dioxide SO2 plus, and the liquid that turns anhydrous copper 2 sulfate blue, it must be water. Phase water. Now let's balance this equation. Fe2SO4 whole thrice. So I will write 2 before Fe. Iron is balanced. What about sulfate? In order to balance the sulfate, you can't write 3 before H2SO4 because you are also getting sulfur dioxide. So what if I will write, first let's balance sulfur. We have 1 atom of sulfur on the reactant side. On the product side, we have 4 atoms of sulfur. So what if I will write 4 before H2SO4? Okay, let's write 4 before H2SO4. Sulfur, it's 4 here, it's balanced. Yes, it's balanced. What about hydrogen and oxygen? Hydrogen, 4 2s are 8. So I will write 4 before H2O. Hydrogen is balanced. Yes, it's also balanced. Oxygen, 4 4 the 16. So on the product side, there must be 16 atoms of oxygen. 4 3 the 12. 12 plus 2, 14. 14 plus 4, just 18. So 8, 16. Product side. This is reactant. This is product side. This is incorrect. So it means 4 will. Let's increase the number. What if I will write 5 H2SO4? So 5 4s are 20 for oxygen on the reactant side. So on the product side, 3 4s are 12. 12 plus 2, 14. 14 plus 5, 19. Again, it's not balanced. Okay, let's try with the number 6 here. Now the sulfur, it becomes 6 this time. So on the product side, we need to write 3 before SO2. Sulfur is balanced. Yes, sulfur is balanced. What about hydrogen? Hydrogen 6 to the 6, 12. So I will write 6 before H2O. Hydrogen is balanced. Yes, it's balanced. What about oxygen? 6 4s are 24 on the reactant side. What about the product side? 3 4s are 12. 12 plus 3 to the 6. 12 plus 6, 18. 18 plus 6, 24. It's balanced now. All are balanced. This will be the final balance equation for this reaction equation. Question number 3. Figure 3.1 shows the apparatus used for the electrolysis of concentrated aqueous sodium chloride using graphite electrodes. So here's a graphite electrode. A, label the cathode on figure 3.1. Cathode is the negative electrode. So this must be cathode. B, explain why concentrated aqueous sodium chloride conducts electricity. It must be due to the presence of mobile ions. In aqueous solution, you have mobile ions. That's why it conducts electricity. Part C1. Name the product formed at the cathode. So in case of concentrated aqueous sodium chloride, you will get hydrogen gas, because hydrogen is less reactive than sodium, or reverse argument, hydrogen is below sodium, or hydrogen have high ease of discharge, low difficulty of discharge. You can write any of these. You can consider these, any of these reasons for the product obtained at cathode. Number 2, chlorine is formed at the anode. When you are having concentrated aqueous sodium chloride, you will get chlorine at the anode. Construct the ionic half equation for the reaction at the anode. So it must be loss of electron at anode. So you have Cl negative ion losing 2 electrons. You know that chlorine exists in the Cl2 state. So we'll write 2 Cl2. Well, let's balance the equation. So it must be 2 here and 2 electrons. D, graphite is suitable as an electrode because it conducts electricity. State 1, other property of graphite that makes it suitable for use as an electrode. It's inert or unreactive. You can either write inert or unreactive. Part E, state the product formed at the cathode when molten sodium chloride is electrolyzed. Now, you are only having sodium chloride. You are not having any kind of H positive ion or OH negative ion in the solution. So you are only having sodium chloride, molten sodium chloride. So in case of molten sodium chloride, you will get sodium at cathode. Moving to next question, which is question number 4. This question is about alkanes and alkenes. A, but1-ene belongs to the alkene homologous series. Members of the same homologous series differ from one member to the next by a CH2 group and have similar chemical properties. State two other characteristics of a homologous series. You have to state any two other characteristics. So you can write any two from these. Any two from these. So homologous series, they have same functional group. Same functional group or same journal formula. They all will follow same journal formula. And there's always a trend in physical properties. So you can write trend in physical properties. There isn't any variation. So you can write any two from these. B, figure 4.1 shows the displayed formula of but1ene. Here it's but1ene. You have to start counting from right hand side. This must be carbon 1, 2, 3, 4. That's why it's but1ene. Ene means it's from alkene. That's why name ending on ene. Number one, explain how figure 4.1 shows that but1ene is an unsaturated compound. So you can write contain carbon-carbon double bond. You see, carbon-carbon double bond. So you can write contain carbon-carbon double bond. What else you can write? Not all the carbon-carbon bonds are single. You see, we have only two carbon-carbon single bonds. The third one is carbon-carbon double bond. So you can write not all the carbon-carbon bonds are single. Number two, give the structural formula of but1ene. Now they are asking you to write down the structural formula. So I'm starting from left hand side, that's fourth carbon, we have CH3. Then we are having CH2. Then we have CH. Now there's a double bond. You have to show the double bond, the structural formula. So I will show the double bond, CH2. So this will be the structural formula. Number three, draw the displayed formula of an isomer of but1ene. So for the isomer of but1ene, you have two options. Either draw displayed formula of first isomer due to the different position of carbon-carbon double bond. You can also have but2ene in this case of but2ene. Now the next isomer must be methyl, 2-methyl but1ene, 2-methyl but1ene. So you can draw the displayed formula of any of these. If you want to draw the displayed formula of but2ene, you must have carbon-carbon double bond between second and third carbon. So now I am saturating this 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, showing the hydrogen atom. This is the displayed formula of but2ene. What about 2-methyl but1ene? Sorry, you can't have 2-methyl but1ene. You have 2-methyl propene. 2-methyl propene. It's not butene, it's propene. I made a mistake. It must be propene. because there must be 4 carbon atoms in all. So you have 1, 2, 3, and there is double bond between any 2 carbon. So I'm showing between these two, and there's a methyl group on the second carbon. So this is the methyl group. One, two, three, four. Second carbon, it's already saturated, no need to place any hydrogen. Third carbon, 1, 2, 3, 4. Placing hydrogen atoms. It's saturated now. This is 2-methyl propene. You can draw any of these in your answer. C. Undecaying C11H24 is present in the kerosene paraffin fraction from the distillation of petroleum. Number 1, give one use of kerosene or paraffin fraction. It's used as jet fuel. So you write jet fuel. Number 2, when undecaying is cracked, shorter hydrocarbon molecules are formed. Construct the symbol equation for a reaction in which undecaying is cracked and the only products are butane, propene, and ethene. So the formula of undecaying is C11H24. You know the formula. Of butane, it's C4H10, propene C3H6. What about ethene? C2H4. So let's count the carbon atoms first. 4 plus 3, 7. 7 plus 2 is 9. So it means we need to balance the carbon and hydrogen also. So if I'll place 2 before C4H10, so the total number of carbon atom becomes, here we have C12 and H24. So if I place 2 before C4H10, what will happen? 2 multiplied by 4 is 8. 8 plus 3, 11. No, we can't use 2 because this is increasing the carbon atoms. So 2 is the wrong option for butane. Let's place 2 before propene. So we have 2, 3 is 6. 6 plus 4, 10. 10 plus 2 is 12. Again, this is also wrong. What if I place 2 before ethene? Now let's count the carbon atom first. 4 plus 3, 7. 7 plus 4, 11. It's balanced. What about hydrogen? 10 plus 6, 16. 2 4s are 8. 16 plus 8, 24. Yes, it's balanced. So this will be the final balanced reaction equation here. D. Propane reacts with chlorine to form chloropropane and one other product X. C3H8 plus Cl2 gives C3H7Cl plus X. Number 1, name product X. Now this is substitution reaction which takes place in the presence of ultraviolet light. So the other product must be obtained is hydrogen chloride. Because in this reaction, chlorine will replace, one of the chlorine atom will replace one of the hydrogen atom. And the product obtained is substituted alkane and hydrogen chloride. Number 2 is state the essential conditions for this reaction. The essential condition for this reaction is ultraviolet, right? So I will write ultraviolet light. You can even write diffused sunlight. Moving to next part. E. Ethene reacts with bromine at room temperature. Figure 4.2 shows the displayed formula of the reactants and products. So here's the reaction. Number 1, calculate the enthalpy change of this reaction in kilojoule per mole. Use the bond energies in table 4.1. So bond energy is provided. We need to calculate the enthalpy change. You know the formula. Energy needed to break bonds minus energy released when bonds are made. So first of all, we'll see which of these bonds are broken. You see, C double bond C, it's broken. So we have C double bond C here, one C double bond C. And we also have Br bond Br. It's also broken. That's why we are getting the product here, which is dibromoethane. The product is dibromoethane. What about the product side? On the product side, we are having bond form, which is CBr. CBr, there are two CBr bonds. And we are also having C bond C. C bond C is also there. So what I'm going to do, there's one C double bond C, so I write 612 plus 1 BR 193 bracket minus energy release when bonds are made. We have CC bond, which is 347 plus 2 bonds of CBr. So you have to multiply 290 by 2. So the final answer, 612 plus 193, we are getting 805 minus 290 multiplied by 2 plus, we're getting 58 plus 347, 405. Sorry, there's a mistake. I need to do this again. 290 multiplied by 2, we are getting 580. 580 plus 347, 927. So 805 minus 927 minus 122. This will be the final answer. Minus 122 kilojoule per mole. Last part of this question. Number 2, describe the color change when a sample of excess ethene is added to a few drops of aqueous bromine. So the color change, what's the color of aqueous bromine? It's brown or orange. Brown or orange. But in solution, when they are saying solution, it must be orange because at room temperature pressure, bromine is brown. So in the solution, it must be orange. So you write orange here. And it will get decolorized. Orange to colorless. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.